Good afternoon, calculus class. We're going to review some solving for variables today. We're going to start with just a simple solving for a variable with just one variable x in it. So in a situation like this, we have some multiple parentheses here and some distributing. So we're going to try to simplify this by first distributing. So we have 2 that can be distributed here, and we have a negative that can be distributed here. So we should just end up with 3 minus 5.4 minus 8.6 plus 2x. That was very messy. Apologize. And then we can distribute on this side as well, because we're going to get minus 0.3x plus 0.8. So then just combining like terms and simplifying, we can see that 3 minus 5.4 minus 8.6 can be combined. And we have on this side 2 plus 0.8. Align everything and get all the x's on one side. We should end up with 2.3x. That would be adding 0.3x on this side, taking this whole difference here and moving it over to the other side. 13.8. You can check my math there. I did that quickly in my head. Just check that. Divide by 2.3. And we get x equals 6. So 6 is the solution for this. And again, I'm just reviewing some solving for variables. Should not be anything terribly difficult. Now we're going to get into some where we're going to simplify and solve for a variable where our answer is going to have other variables, in this case p and r, in it. So the first thing we're going to have to do is get the q's all isolated and together so we can factor them out. So by distributing this r, we should get p squared q minus rq minus r equals, and then we can distribute this 4 over here as well and get 4pr, or 4p plus 4r. Now we can see that we have q we can factor out here. Add the r to the other side and simplify that. So we're just going to get q and then p squared minus r equals 4p plus 5r. And then our last step would be to divide by p squared minus r to get q equals 4p plus 5r all over p squared minus r. So this just working with operations that you're all familiar with, distributive property, combining like terms, and then inverse operations here to solve for a variable. Nothing terribly difficult. Now we're going to be solving some problems where we have to factor. And in this situation, we're going to have to actually FOIL this out or distribute this before we solve. A common error: we cannot take x plus 1 and set it equal to 15 and x plus 3 and set it equal to 15. That only works when it's equal to 0. We don't have any other property that says the product of things will equal a number, can separate them. There's too many solutions that would make this true, this product equal to 15 for x's. So we can't do it that way. So we have to rewrite this so that we have 2 parentheses being multiplied equal to 0. And before we can do that, we're going to have to FOIL this out to do that. So we're going to first take and FOIL out x plus 1 times x plus 3. So we'll get x squared plus 4x plus 3 equals 15. Now we're just going to subtract 15 so that we end up with 0 over there. So we'll get minus 12 equals 0. Now, if this can be factored, we can factor it. Otherwise, we would just use the quadratic formula to solve for this. I think this one can be factored. We're going to get x minus 2 and x plus 6. I think that works out because 6 minus 2 is 4, and 6 times a negative 2 is negative 12, so we're good. So we get 2 solutions here. I expand this here. We get x equals 2 and x equals negative 6. Always check your work. There's really nothing that would make this undefined, but putting 2 back into the original problem satisfies it, and -6 in for x satisfies it. So there will be situations where you need to check your solutions, and we'll do an example here in just a moment. So now we're going to be dealing with exponentials. So we have e here. We're going to solve for x. You'll notice that there's an x in the exponent. It may be possible to get that out of there, and we'll go through some properties later on. But right now we're just going to factor it and see if it works out. So if we factor out an e to the x, we get 1 plus x equals 0. Well, e to the x will never equal 0. There is not an exponent that I could put in here and put it on e that would get us 0. So no exponent will ever equal 0. The only way you can get 0 is if we have a product. So in this case, that is no part of the solution, so we don't have to worry about getting that x out of there right now. But we do have to solve for this, and we get x equals -1 is our solution for this problem. So just take -1, substitute it up here. It does check out that we end up with 0. So we'll go through some more examples with exponential functions in our work. And you may have some questions, and we'll answer those as necessary. Now we're going to be working with fractions. So we did that whole section on simplifying fractions and rewriting problems for a reason. In calculus, often we have to solve for variables that are involved in fractions. So the first thing we're going to notice here is that this here, x squared plus x, is really just x times x plus 1. So if I multiply both sides by x times x plus 1, we can actually cancel out this denominator and then remove the denominators over here. So we're in a sense clearing the problem of the fractions. So to clear the fraction, or clear the equation with a fraction, is just multiply by the common denominator. And what that will do is it will clear everything. So multiply this side by x squared plus x, and then this whole side over here by x squared plus x. And as I pointed out here, this here, x times x plus 1, will allow us to cancel this. So that cancels, and we get just 2x squared. That x plus 1, let me back up here for just a second. I don't want to confuse you. I may have tried doing something there, and I hate for that to confuse you. So let me back up here. We have to distribute this. So we're going to distribute this to both of these. So we're going to get x times x plus 1 times 2x over x plus 1. And then we're going to get minus 3 times x plus 1. So we have to actually multiply both by it. This side, we were able to just cancel those and get just 2. Now I can just work on that canceling, and we get 2x squared minus, we can distribute both the 3 and the x, so we'll get 3x squared minus, don't forget we're distributing a minus here, minus 3x equals 2. So now it's just a matter of seeing if we can simplify and factor this to get something that can be factored. So we're going to end up with, in this problem, negative x squared minus 3x minus 2 equals 0. And to factor this one, I really like this to be positive. So I think what I'm going to do is I'm going to move everything over to the other side and make everything positive. It makes it a little easier to factor when that leading term is positive. Now I can see that I can factor this into x plus 1 and x plus 2. Okay, so I just added these over to there and made this left side 0. So we get two answers, x equals -1 and x equals -2. This is an example of where we need to check our work. x equals -1, if I put it up here in the original problem, there was an x plus 1 in the denominator, that'll make that an undefined function because you cannot divide by 0. So this is going to be a situation where we have an answer that doesn't work, and x equals -2 does work in the original problem, and it doesn't make it undefined. So x equals -2 would be the only solution. Okay, we're going to do one with square roots, and in order to get a variable out of a square root, we have to do its inverse, and the inverse of square roots are squaring. But before we square, I really would just like to isolate. So I'm going to add this x to the other side and get x minus 3. Now I can square both sides. An error that a lot of students make is they just square the square root and they forget that there's a 2 out here. That ends up being 4x equals x squared minus 6x plus 9. We have to FOIL this out. Now we can subtract 4x, and we get x squared minus 10x plus 9. This factors into x minus 1, x minus 9, and we can see we have two solutions. X equals 1 and x equals 9. Now this is an example or a situation where you have to check both of your answers again. You want to make sure that they work in the original problem. So you'd have to take the square root of 1, so you'd have 2 times the square root of 1 minus 1, and you got to see if that's going to equal -3. Well, we can see that this is going to be 2, and 2 minus 1 is not equal to -3, so that one doesn't work. X equals 1 does not work. 9, I think, does. We get, let's see, 9, 3, 6, 6 minus 3, -3. I'm off by a negative here. I will check this one and have it confirmed for you tomorrow. I'm wondering if I have a sign problem wrong up here, because we should end up with 3, not -3. So I will check this one before you come into class tomorrow. So come to class with this example. The 9, I must be missing a sign here somewhere. We should get a -3 as our final answer. Okay. That'll be the last example. Bring your notes to class and any questions, and we'll do some classwork tomorrow.